welcome to EVPM. Let's talk a little bit about schematic and PCB design. We'll be using KiCAD, the latest version 7. It's a free software that you can download right now and get started. So before we even open KiCAD, let's take a look at the design process. So we'll start off. So we have the schematic editor. This is where we begin. This is where we draw our schematic. This is where we make all of our electrical connections. And if there is a component that we want that is not a part of the library, we go into the symbol editor. Here we build the symbol of the part that we want. This symbol doesn't have to look like the part at all. This symbol could look like anything. As long as it has the electrical connections, we're fine. So for example, you have a 8-pin package here. You can just draw a box and 8 pins. It doesn't have to look like the physical component, or you can draw an op-amp like this. Even though the op-amp will not look like this in real life, nothing's preventing you from using the symbol editor and just drawing your symbol in any way you want to. Then once we're done with our schematic is when we go over to the layout or the routing stage. So this is where we take all of our symbols and transfer them into footprints. These footprints though will have to match the physical package that the supplier or the manufacturer provides the product in. So even though our symbol looks like this for the op-amp, we have to make sure that our footprint does indeed look like the package that we're going to solder onto that part of the PCB later. A lot of that is done for us. We will just assign symbols, footprints to the parts, and then the software will do the conversion and bring everything over. So this is our layout stage, and should there be the case that we do not have a footprint, we can go into our footprint editor and we can build a footprint. So at no point in time do we need to be nervous that there will not be a part in the library, because we can expand that library and add whatever part we want. As long as the manufacturer provides some sort of footprint schematic, we can build that footprint in the editor and place it in our layout. So I just wanted to go over some of that basic design flow before we get started, and I'll show you why now. So let's open KiCAD, and that's why I wanted to go over the design flow, because I don't want you to be overwhelmed by everything you see here. So let's go over. Here's the schematic editor. So here's our schematic. Here's our schematic editor. Here's our symbol editor. Here's our PCB editor. This is our layout. Here's the footprint editor. Here's the Gerber viewer. This is when you're finished with your PCB and you want manufacturing files. So this will be all the files necessary for the PCB manufacturer and assembler to put together your board and to manufacture it. Image converter is if you want to put bitmap images and convert them into schematic symbols or PCB footprints. Calculator tools is very good if you want to do some physics calculations. It says you're calculating resistance, current capacity, and all that kind of stuff for your PCB trace. For example, how much current can I have on this trace with, what's my characteristic impedance, and all that stuff. And then the plugin and content manager. So let's just dive into it with the first step, actually drawing the schematic. So in this project, we're going to be using an STM32, and we're going to build functionality that we want. Let's create a new blank project, give it a name, and then we double click on the schematic file, and here we are. Here's a blank project. We have tabs up top, we have some parameters to the left, and we have some icons on the right. On the right is what we're going to need to draw. On the top is going to be our settings and our functionality. On the left is going to be some parameters. We're not going to have to use much of this, and I'll help you every step of the way for the most common used functionality. So you can click here next to the save icon, and this will give us a little bit of a setup opportunity. Scroll down to project. Here we see net classes. Here we see wire thickness of 0.1524 millimeter. You can add new net classes. Maybe if you want power, you can increase this maybe by 2 times if you want to make the power net class thicker. And let's stay with default for now. You can exit this window. Right next to it is another settings icon for the paper, and here we might want to print the dates, print the revision. Let's just go with 1.0. Title, STM32 demo board company, my company. Comment, maybe SMCU or STM32 MCU. Great, we press OK, and as you can see, our sheet has been updated with our current information. So when I press Control and I scroll, I go left and right. When I hold Shift, I go up and down. The scroll wheel zooms in or out. Right click moves the sheet. Left click selects. If at any time you want to change anything, you can go to Preferences, Mouse, and Touchpad. Here you can choose what the middle button does, what the right button does, some of the zoom configurations. When I do left shift and scroll, I go up and down, but you can choose that to be left and right, and control to be up and down. That's what I prefer, so I will do that. So now when I hold shift, I will pan left and right. It's just what I'm used to. You can navigate quite well just with the right click and the scroll. You can scroll in and out to get wherever you want to. So the main hero of this board is going to be an MCU. So let's begin by placing a component. I press on the add symbol icon, and this is where our library is. This is where we will choose our parts. We are looking for an STM32. I can hide this and get the library here. Here we see the series, F0, F1, F2, F3. These get progressively stronger. Let's keep it relatively easy for this demo. A big part of PCB design and schematic design is actually looking at what's on the market. So we have DigiKey, we have Future Electronics, we have from ST themselves. So let's take a look at STM32 and see what we have. We're looking for microcontrollers, looking for what is in stock, descending. Great. So here's an STM32 K8T6. There's a lot of them in stock. Should get the job done. Let's see if we can find this in our KiCAD library. Yes, it is there. But if you search with an X at the end, great. So there's a lot of these in stock. We have that here. We even have the data sheet here. So we don't have to look any further. This is going to be our microcontroller of choice. I double click and I click. I press escape to escape the select part or add a symbol, a prompt. And here we are. We can move this a little bit out of the way, give us some space. One thing we might also have to do before we get started is to fix the grid to our liking. So it is in millimeters right now, which is excellent. You can right click here and access the grid properties. And here we can choose the grid. I would prefer a millimeter grid. So we can do 0.25, 0.25, press OK. Make sure you select user grid here. Okay, 0.25. There we go. Now when we click and move, it'll snap to our millimeter choice. If you're watching from the United States, you might have to adapt this to be inches or whichever unit you want. I'm just using millimeters because I'm based in Europe, but that is no way a requirement. Feel free to use whatever you think fits best for your application. So let's just take a look at the MCU and see what will work. We only have one VDD pin, so this is a small package. Let's take a look at what package this is. So double click and here we go. Package QFP32. Alright, let's compare that with the datasheet. It's this one. So it's a small MCU. Pinouts and descriptions. Here we go. LQFP32. This is it. We only do have one VDD pin we have to worry about. You can do Control F and search for VDD in the document. There's a lot of these showing up, but we need the power supply scheme to see what we're working with. So this device requires 2 volts, 3.6 volts. Okay, so that's simple enough. Then we have the not reset pin. So if this is a 1, we are not resetting. So we might have to pull this up to a 1 to keep this from not resetting on us. Pulling it low will reset it. And there are these port pins, port C and port B, as well as port A, and ultimately a ground pin. So there's not much to worry about here in terms of getting the MCU to work. We just need power, ground, and this one pulled high. Let me do one quick search for boot modes. Usually these pins share functionality, or the functionality is shared on one pin. So we need to find the boot pins. And this is our package, so we're looking for the values here on PA14. PA14 here. So whenever we get information like that, I actually like to double click on this and edit the symbol. And this will only edit the symbol for us in this instance. This will not change the symbol in the library. So what I would like to do is to add the text here for boot on this pin. So I'll click on the text, I'll type in boot 0, and I will simply add that here. What you can also do is a slash and change the color to be that gray or green rather. Defined color seems to be this gray here, really sure. Okay, so now we know that PA14 is boot. 0. We can save these changes and exit the symbol editor, and now our particular MCU symbol has this additional information. This is helpful if you're working on a big project with a lot of engineers to add or to edit the symbol to what you added it to. So if you're using this functionality on pin 14, it's a good idea to write that out so whenever somebody looks at the schematic, they'll know what you're using it for. Alternatively, you can add a comment and place it somewhere near. This will greatly help future engineers to examine your schematic. For now, I decided to just add the boot 0 characteristic on the pin here.